Today we're going to talk about multiplying and dividing rational expressions. A rational expression is an expression that is the ratio of two polynomials. It's just like a fraction, but with polynomials. So a rational function is the form of, so we have a function f of x equals n of x over d of x, where d of x is not equal to 0. So a simplified rational expressions, they do not have any common factors in the numerator and denominator. So we're going to practice multiplying fractions just to remind ourselves of how to do them. So let's review. We first factor. Remember that if you have anything over anything, so the same thing over the same thing, that's equal to 1. So anywhere you can find the situation, you should cancel as early as possible to make this process more simple. Then multiply straight across, numerator times numerator and denominator times denominators, and simplify the fraction. So if we look here, I know that 9 breaks down into 3 times 3, and the 4 breaks down into 2 times 2. So really we have 3 times 3 over 5 times 4 over 2 times 2. So the only common factors we have are the 5. So 5 over 5 we know is equal to 1, so those cancel out. Nothing else cancels out, so we take the numerator times numerator, which is 3 times 3 is 9, and denominator times denominator, so 2 times 2 is 4, so 9/4. Looking over here, we're going to do the same thing. So first I want to break down that 48. So 48 breaks down to 2 and 24. And then the 24 breaks down into 2 times 12. And I keep going, but I notice there's a 12 here and here. So those are going to cancel out. So I'm going to stop. So that means we have 2 times 2 times 12 x squared. And if you want, you could actually write this as x times x over 12 times x, and that's being multiplied by 1 over 4x, and 4 actually breaks down into 2 times 2, so let's write 2 times 2x. So we have this 2 and this 2 cancels out, this 2 and this 2, the 12s, this x and this x, and this x and this x. So notice that everything canceled out. So if I have the same thing over the same thing, well then of course that means that is equal to 1. So let's review dividing fractions. To divide fractions, multiply by the reciprocal and then follow steps for multiplying fractions. So here, first we multiply by the reciprocal of the second fraction. So this would be 3/8 times 6/5. And then of course the 6 breaks down into 2 times 3. And 8 breaks down into 2 times 4, which breaks down into 2 times 2. So this would be 3 times 2 times 3 in my numerator over 2 times 2 times 2 times 5. So notice that the only thing that looks like it cancels out are the 2. So in my numerator, 3 times 3 is 9. 2 times 2 is 4 times 5, which would be 20. So 9/20. Looking at the next one, we do the same thing. So 1 over 2x. So first change this to multiplication and flip. So this would be 5 over 2x when we multiply by the reciprocal of the second fraction. And just to remind you, we could also write this as 1 over 2x divided by and then 2x over 5. So you guys have worked with, this is a complex fraction, so this is the same thing as this, it's just another way of writing it. So here we notice that nothing cancels out, so we're going to multiply straight across. So 1 times 5 is 5, 2 times 2 is 4, and x times x is x squared. So 5 over 4x squared. So simplifying rational expressions now. So first we factor the numerator and denominator completely, and then simplify by canceling out common factors. So here are some examples of simplifying each rational expression completely. So first thing you would do is factor. So this is already in factored form, so that makes it easier. And then I'm going to cancel out my common factors. So I notice that the x plus 11 and the x plus 11, those are common factors, so those are going to cancel out. And that means I'd be left with in my numerator x minus 8 over x minus 20. Now be very careful because you cannot cancel out these x's right here, which students often try to do. This x is attached to the 8 and this x is attached to that 20. For instance, just as an example to show why you cannot, so like if I had x plus 1 over x, If you were to cancel these out, you're saying that this is equal to 1. So let's try this out. Let's say let x equal 2. So if I let x equals 2 into this original problem, this would be 2 plus 1 over 2. We're saying that should be equal to 1. Well, 2 plus 1 is 3 over 2. That does not equal 1. Therefore, you cannot cancel those out. So be very careful. Do not do this. So those terms do not cancel when you have it attached to another term. So you cannot cancel these. So this is my solution. Looking at the next one again, we're going to look for common factors. So it's already in factored form, except for I notice that these two are very similar, except for they're written opposite. This is x minus 5 and this is 5 minus x. So you can rearrange this to be negative x plus 5. And notice that they're not the same, but they're very similar. What's the difference? The signs. So if you notice the signs are different, that means you can factor out a negative 1 from either of these two. It doesn't matter which one. So if I factor out a negative 1, that means this would become x minus 5. So if I rewrite this, I have x plus 3 over x minus 5 times x plus 2 over negative 1 times x minus 5. And then I'm going to rewrite this as x plus 2 and x minus 8. Now I can go ahead and look to cancel out common factors. So I see that I have x plus 2 and x plus 2, x minus 5 and x minus 5. Those are my common factors. So then the next step would be to multiply across or just get what's left over. So x plus 3 is left in my numerator, and in my denominator, negative 1 times x minus 8. So this would be our solution, which of course we could distribute that negative 1. So this would be x plus 3 over negative x plus 8. So if you leave the answer like this, I'll accept it. Technically, when you simplify something, you shouldn't have parentheses left in your answer, but for right now, it's okay if you do. So looking at the next one, we're going to do the same thing. So here, first you want to factor. So these were both in factor form. These last two are not. So there's first thing I want to do is factor. So remember, if you have more than one term to factor, you need to think about all your factoring techniques. Factor out your greatest common factor, which is 20. So if I factor out 20, I get 20 times x, 2x plus 1. And in my denominator, my greatest common factor between these two terms would be 10. So 10 times x plus 3. So now that this is being multiplied and this is being multiplied, there's no other terms attached to it. I can simplify that. So I know that 20 over 10, well, 20 breaks down into 2 times 10. So I'm going to leave it like that. So this is 2 times 10 over 10. The 10s cancel out to give me 2 over 1 or just 2. So that means, because these don't cancel out, this is really 2 times 2x plus 1 over x plus 3. And that's going to be our answer. Again, this is not completely simplified because technically you would multiply that 2 in the numerator, so it would be 4x plus 1. But for right now, if you want to leave it in factored form, that's fine. Or if you want to multiply it out, that's okay too. It just would take you a little bit longer. Looking at the next one, now we also need a factor. So look for your GCF. There is none. There's two terms here, and so we're going to look for patterns. It's a plus sign, so we can't use the difference of two squares. Also, this is being cubed, so I'm going to try the sum of cubes. So can I take the cube root of 27? I can, and again, if you don't remember what the cube root is, you can always use your calculator. So if I go to math and number 4, the cube root of 27, I know is going to be equal to 3. So here we have our sum of cubes formula. So x plus 3, so remember it's the cube root of these, so then you do same sign, opposite always positive. First term squared, first times second, second term squared. And in my denominator, I'm going to look at this. I don't have a greatest common factor. I have 3 terms, so I'm going to look to see if I can find factors of 12 that add up to 7. So factors of 12 that add up to 7 would be plus 3 and plus 4, because 4 times 3 is 12 and 4 plus 3 is 7. And then I would notice that I have common factors here that can cancel. And then this doesn't factor any further, this trinomial, which we talked about when we talked about factoring special patterns. It doesn't factor further. So x squared minus 3x plus 9 over x plus 4 would be my answer. Now again, you cannot cross out those x's because they are attached to other terms. All right, so now we're going to talk about multiplying rational expressions. So step 1, factor each expression completely. Step 2, cancel identical factors between the numerator and denominator. Step 3, simplify/multiply the result. You can leave your answer in factored form. So remember, technically simplifying means no parentheses, combine like terms, but it's okay for now to leave it in factored form. But if this was like an SAT or ACT, they would probably write it without, the parentheses. So here, if we simplify this, I would first factor completely, so it's already in factored form. Then I'm going to cancel out identical factors between the numerator and denominator. So I start with the x plus 4, I don't have one down here. X minus 6 I have here, so that cancels out the x plus 2 and the x plus 5. So then what are we left with? In my numerator, I'm left with x plus 4 over x minus 3. And again, you cannot cancel those factors, so this would be my solution. Looking at question 10. So now for this one, we do have to factor, so look for a greatest common factor. So 2x in the numerator, so x plus 2. Here, factors of 12 that add up to 4 would be x plus 2 times x minus 6. Over here, multiplication. And so we're going to factor this again. Factors of 18 that add up to negative 9. So x minus 6 and x minus 3. This stays 2x. Now I can cancel out common factors. So I see these are common, they cancel out. The x minus 6 cancels out. The 2x here and here, those are separate terms. The 2 cancels out with the 2 and the x cancels out with the x. And then the only thing we're left with is x minus 3. So that means this is just x minus 3. Really, it's over 1. We don't need to write the 1 in denominator. Same thing, first we want to do is go ahead and factor. So if I factor this, we have 3 terms, no greatest common factor, factors of negative 20 that add up to x. So x plus 4 times x minus 5. Down here I do have a GCF, which is 2x squared, and then that becomes x plus 3 times, here I have 2 terms, but I also have a greatest common factor of 4 and x. So that becomes x plus 6. And down here I have 3 terms, so I'm looking for factors of negative 15 that add up to 2. X plus 3 times x minus 5. And then I can cancel out common factors. So let's see, the x minus 5s cancel out. The 4 breaks down, so I can simplify that one. This breaks down into 2 times 2. So that means this 2 cancels out with this 2. One of the x is going to cancel out because remember we can write this as x times x. So this x cancels out with this x. We have 1 left over. And it looks like that's it. You cannot cancel out these x plus 3s because they're both in the denominator. You can only cancel out terms if they're in the numerator and in the denominator and common. So that means we're left with in my numerator x plus 4 times x plus 6. And then don't forget we also had this 2 that did not cancel out. So I'm going to put that in front. Divided by, and again we have this x here. So x times x plus 3 times x plus 3, so we can write that as x plus 3 squared. Now again, technically this is not completely simplified because you would have to multiply, FOIL, and combine like terms, but we're going to leave it in factored form for now just to practice the steps. So here, if you don't see your fraction over anything, and remember it's over 1, so we're going to factor, so this doesn't factor at all, so we leave it as x plus 5. Here I have 2 terms and a minus sign, and I see a 3 here, so difference of cubes, so the cube root of 1 is 1. So I'm going to set up my binomial times my trinomial. Same sign. Opposite, always positive. So this is x minus 1. First term squared is x squared. First times second, ignoring the sign, so just be x, and second term squared is 1. Times, and here I see a GCF of 4, so that gets taken out. And that becomes x squared plus x plus 1. Now I look for common factors. The x squared plus x plus 1 here and here cancels out. And it looks like that is the only thing that cancels out. So we're left with 4 times x plus 5 over x minus 1 times 1, so just x minus 1. And we can go ahead and leave it like this. And again, if you want to distribute that 4 in, you can, because that's technically simplified, but for now we can just leave it in factored form. Next thing we're going to talk about is dividing rational expressions. So step 1, flip or use the reciprocal, the second term. So flip the second term and change the division symbol to multiplication. Then factor completely, cancel identical factors, and simplify/multiply the result. And again, you can leave your answer in factored form for now. So for the first one, we want to go ahead and make this multiplication and flip. So this is 2 times x minus 1 times x minus 2 over x plus 4. So you change this to multiplication and flip the second fraction. I'm going to simplify that to 2 times 2. And now I can cancel out common factors. So if we look at my numerator, this 2 and this 2 cancels out. We do not have an x minus 1 down here, but we do have an x minus 2. We don't have an x plus 1, but we do have an x plus 4. So if I multiply straight across, x minus 1 times x plus 1 over 2, because I forgot this 2 here, so 2 times x minus 3. And again, we can leave our answers in factored form. So technically it's not simplified because simplify means no parentheses, combine like terms, but we're going to leave it in factored form for now just to practice. So let's keep on going. Why don't you go ahead and see if you do number 14 on your own. When you're done, you can unpause the video to check your work. So for question 14, again, same thing. First thing I'm going to do is change this multiplication and flip this fraction. So we have x minus 5, and then here, this would be, and I'm going to factor out the GCF while I'm doing this, so that would be 9x times x minus 2. This becomes multiplication. And then in my numerator, this becomes 2x squared minus 5x plus 2. This goes in my denominator, x squared minus 11x plus 30. So this becomes x minus 5 over 9x times x minus 2 times. Here I can factor out a GCF if I have it, which I do not. So I can do my Swedish fish factoring. So Swedish fish don't really swim. So that means 2 times the 2. That gives me x squared minus 5x plus 4. Factors of 4 that add up to negative 5 would be x minus 4 times x minus 1. Divide by what we moved, so that was the 2. Reduce. So this becomes x minus 2, and then if it doesn't reduce, swing that number in front, so 2x minus 1. So x plus 2 times 2x minus 1. And then down here, we want factors of 30 that add up to negative 11, so 5 and 6, so x minus 5 times x minus 6. Now that I have it factored, I can go ahead and cancel out common factors. The x minus 5s are common. I think that's it. X minus 5. Oops, and you know what? I just realized I wrote plus 2. That should have been minus x minus 2. So that means that this cancels out with this term here, and then that would be it. So if I go straight across, I'm left with 2x minus 1 in my numerator over 9x times x minus 6. Of course, 9 breaks down into 3 times 3, but it doesn't cancel out with anything from my numerator. Go ahead and see if you do number 15 on your own. When you're done, you can unpause to check your work. So for question 15, same thing. This we're going to go ahead and change into multiplication. So 3x squared plus 13x minus 10 over 6x squared times, remember this is over 1, so that becomes 1 over 3x squared minus 2x. And then we want to factor this. So first thing you want to do is look for GCF. There is none, so we're going to do our Swedish fish don't really swim factoring. 3 times negative 10 is negative 30, so x squared plus 13x minus 30. Factors of negative 30 that add up to 13. So x plus 15 times x minus 2. And remember, if you forget your factors, you could always go to your calculator, y equals. So let's say I couldn't remember what my factors were. So if I went to my y equals and did negative 30 divided by x and then looked at your table, oops, we need to go back to second window because we remember changed that to ask when we were doing our last unit. So I'm going to put it back on auto. And when I do that, notice I get my factors. So that's another way if you have a hard time finding your factors to look at them. D stands for divide what we moved, which is the 3. Reduce, so it becomes x plus 5. This doesn't reduce, so the 3 goes in front, 3x minus 2. And you can always check your work by foiling this out to see if you get the original equation, which we do. So x plus 5 times 3x minus 2 over 6x squared times 1 over, here we have a GCF of x, so it becomes 3x minus 2. And then I'm going to look for common factors to cancel. So we have the 3x minus 2, and it looks like that is all. So in my numerator, x plus 5 times 1 is just x plus 5 divided by 6. Didn't cancel out with anything from numerator, and x squared times x is x cubed. Because remember, you multiply something with the same base, you add the exponents. So down here it says list any factors that cancel. If nothing can cancel, write NA. So go ahead and do this on your own. When you're done, you can unpause the video and check your work. So looking at this first one, which it says which factors cancel. So the x plus 5 or x plus 5 to leave us with x. So x plus 5 cancel, and the answer to this is just x. Here, this breaks down into 4 times 4, and of course that breaks down further, but then I would notice the 4's can cancel, so 4 cancel, and that leaves me with 4x then when I cancel. Over here, keep in mind that this is 3 plus all of this. It's not being multiplied, so I cannot cancel out these terms because if I simplify this, I have 3 plus x plus 2. If I combine my like terms, I get x plus 5 over x plus 2, which means these are not common, so none of them cancel out. Looking over here, again, you cannot cancel out those 5's because this is attached to an x, so none. Over here, the x plus 3 cancels out, and that means it simplifies into x plus 5. Here we can cancel out the 4's and the a's, and then we're left with b, so 4a cancels out. So again, you have to be very careful because if these had any pluses or minuses in between, you could not do that, but since they are just multiplication and division, you can go ahead and cancel them. Okay, so that is it for multiplying, dividing rational expressions.